Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Rat Run 28, Hypothesis by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Aim of experiments. F and P must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, share cells, cross themselves or each other, or pass through any thick maze walls. As well as moving orthogonally, they may move diagonally if there's a 2x2 space in which to do so, but they may never pass diagonally through a round wall spot on the corner of a cell. So as an example, you could have F, I'm assuming F is the top one. F could go, we can't do that. F could do something like this, right? And you could go diagonally here, but you could not go diagonally there. This diagonal is perfectly fine. This diagonal here is not because it goes through a round wall space. And again, a round wall spot, I guess. Again, you cannot go, the pass cannot cross itself, cannot enter a cell more than once, share cells, or cross itself or another path. And they can't go through thick maze walls. Okay. We have teleports, where entering a teleport will cause a rat to be instantly transported to the matching colored teleport. So actually, this is not a valid route because it goes through a teleport here, C, and it would have to instantly teleport to that cell there instead of continuing on this route. So this is an example of how the teleport works, and then it would start from there and go in another direction. Okay, go there, teleport to here, and then go to something else, right? So those are examples of how teleports work. Also, matching teleports always have identical digits, but teleports that don't match always have different digits. So the digit in C has to be the same digit, but it must be different than all the other digits which are labeled, which is A through E, besides C. So so for example, say we had a 3 here, then this would have to be 3 here for the teleports to work. We have one-way doors where a purple arrow may be passed through in the direction the arrow is pointing. So if you go through an arrow, you cannot go this way. You have to go this way through the arrow. And that's for all arrows. And an arrow always points to the smaller of the two digits it sits between. So it acts as a greater than sign. So for example, you could have something like 8 and 7 there, and that would be perfectly fine on the one-way doors. We have grapes, where a green grape sits between two digits with a difference of at least 5. So, for example, if this were, say, a 3, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And finally, the test constraint. In this experiment, F may only visit even digits, and P may only visit odd digits. So we don't know which one's F and which one's P. You must determine which rat is which. Okay. Does it say that you have to go to the cupcake? Yeah, you must both reach different cupcakes. Right. So the cupcakes are here and here. Interesting. So, one of the rats only visits even digits, and the other rat only visits odd digits. So, in addition to not being able to share cells, they obviously can't because One's going to be only through even digits and one's through odd digits. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. That's interesting. So, for the grapes, since they have a difference of 5 between them. Okay, this rat definitely has to go this way because there's no way that she can go anywhere else. So let's go there. This rat can go in certain directions. This rat cannot go. Oh, it could go all the way around here. Interesting. Huh. This rat cannot go just directly here because that's too many different digits here, right? She could go diagonally, but then she would block the other rat from going to a different space. So that doesn't work either. So she can't go this way. She can't go here. That would block the other rat from exiting out. She can't go this way. Where can she go? She has to go then in this direction. Okay. The other rat then has to go this way. And... It seemed kind of problematic. Wait, maybe not. Okay. Right. So, of the paths, obviously you cannot go this way for the red rat. You can't go that way for the red rat. You can't go here and then there. That's not because that blocks all paths. You can't go this way because then that would be too many cells, either way direction that it goes. So of the paths, you can only go here, and then it limits where you can go. So you have to go that way. You cannot go to this direction, so you must go down to the A. That means the green rat has to go this route, and cannot go this route because that would be too many digits of the same set, right? So there's 5 odd digits and 4 even digits. If you tried to have the green go more than the green and red paths cannot be more than 4 or 5 per row, per column, or per region. So if she were to go this route, that would be 6 in the region, which is why she can't go that way. She has to go then this way, right? This is kind of problematic too, because if she tries going that way, that's too many cells also in that region. So she has to start teleporting. There's... we don't have a guaranteed. She has to go this way, though. So that is guaranteed. Let's make it green and pink. I usually use different coloring for odd and even, so that's why I usually use red and blue for odd and even. So let's use green and pink for now so that we can figure out which cells are green and which cells are pink. So this is not green, that's pink. These have to be green. Okay. Green can never reach here then. Pink has to be the one that actually reaches this cupcake because there's too many cells that are green already in box 9. So to reach the cupcake, then pink has to go this way. And green has to go this way, which means pink has to go that way. Pink has to go through the one-way doors. And possibly go through E. Green can only go from here. Potentially could just go that way, right? Hmm. Okay. So they are... So green, because she goes through 2 grapes, she has to be odd. Because 4... Well, you could just... Yeah, you can't... Okay. She goes through 3 grapes. 2 grapes. And 3 of them are in the same region, right? These cells and that cells. So one of them then would have to be guaranteed to be 4 or 6. But 4 or 6 can only be next to odd digits. Or sorry, 4 can... Yeah, that's true. 4 and 6 can only be next to odd digits, which are 1 and 9, and that would break that path. So green has to be the even digit, or sorry, the odd digits. And pink has to be the even digits, interestingly enough. So then we can change these colors then. So who's F can only go through the even digits. So F is the bottom cell. And P can only go through odd digits. So P is a top rat. Okay. Well, we know then. So F can only visit even digits, and so it's blue. P can only visit odd digits, which is red. We have 4 odd digits in box 9, so the E has to be an odd digit also. Which means F cannot go through it, so F has to go this way. So the path has to be like so. That means P has to go through C. And obviously has to go through here. That's 5 odd digits then, already guaranteed. In row 1. So therefore the remaining digits in row 1 have to be all even, which matches with A. We have 4 odd digits in and 4 even digits in box 3, so this must be odd. Okay, in column 8, we have 1, 2, 3 evens and 5 odds, so the last digit is even. In column 7, we have 4 odds, 4 odds and 4 evens, so the last one has to be odd. This must be odd. So B is even because it matches that digit. We have 4 even digits in column 6, so the rest are odd. D is odd. How do we know D is odd? I don't know how we know D is odd. I don't. Oh, it's just red. Apologies. You don't know it's odd. It's just the color of the background was interesting. Okay, so we don't know what color D is. I was just wondering how that was the case. Um. So P has to go to one of these two cells. We don't know which. Okay. Um. Hmm. Okay. P cannot go all the way down here. If she goes this route, so if she goes to here, she has to continue this way because she can't go that way through the one-way door. Can't go through the wall, but there would be six odd digits if she went this way. So she has to go this route, no matter what. So these are definitely on the path. We don't know. So is that. So therefore that's odd. She could go diagonally, she could go down one, and then that way we don't know. Okay. These are all even digits. Okay, so with going this way, the problem with going this way is that there are already 3 even digits in the region. If we try going that way, there's no way that it can go out any other way. So the F has to go through this route because there's no way if she goes this route, she's blocked from exiting out of the box. I guess she could do that and then go that way. So we don't either way, so she has to go through B. So B has to go around. So then these are even guaranteed. She could go that way, then cut back here. That is potentially possible. She could just also go straight through. We don't know. D is possible. Is D possible? So say she went through D. I don't think D is possible, actually. If she goes through D, how does she even... Yeah, that doesn't even work. How does she get to here, right, is the question. And the problem is you can only have Yeah, if she tries to go through D, how is she going to connect this way? She's going to have to go through at least 3 cells next to a grape, which means one of them is going to have to be 4 or 6. So, but she can't go this route because one of them's 4 or 6, which would be next to 2 or 8, which is impossible. Because 4 and 6 can only be next to 1 and 9 because they're 5 apart from that. She goes that way, yeah, and then she can't go through the cupcake. She can't go this route because again, you'd have 2 8 2 8 4 6 next to a 1 9. So you cannot go through D. So she has to go around D, essentially, around the red cupcake. And go this route. She could potentially do something funky like this. So she cannot go that way. She has to eventually, well, no, she can't go all the way here. That would be too many evens in the column. So she eventually has to get to here. And I'm guessing that P has to teleport to D. Okay. Well, we're guaranteed one of these cells has to be odd because we already have 3 even digits in box 1. So since one of these is guaranteed to be odd, we can only go 4 in this route. Um, how does she do so? That is a good question. With blue also trying to go around. Hmm. Well, blue can't go through D, so blue is guaranteed to have to go that route at least. It can't go this way because they're going to be crossing if that happens. But the problem is if blue is here, how do you get to D? One, two, three, four, five. That's too many. Um, can't do something funky like. Okay, so blue's gonna have to go that way, which means blue has to go that way. Hmm. I don't know if that works. Hmm. So what other path can they take? I don't know if there is any. Can't go in diagonals here or here, so that's bad. Going diagonal here doesn't help. Hmm. Hmm. Oh. No? Hmm. Can't go this route. Yeah, you just can't go this route. It's too many digits that are odd then. Huh. Maybe E? Yeah, I think she has to go through E. Because she can't go this route. Because then there's too many odd digits in column 1. Because one of these two is odd. Guaranteed. At least one of these two is odd. So she has to get through D. So blue has to go this route, which means red has to go this route. Um, we're guaranteed this. Okay. So that means we have to be guaranteed to go this way. D then to here. So these are red. We have 4 evens in column 3, so the rest have to be odd. We have 5 odds in box 7, which means we need the last one to be even. Um, So technically, she doesn't have to go that path specifically. Okay, so F is it no P goes through odd digits, so P has to go this route. So P must go here. She must come from here. These are odd. Cannot go this route. So she either has to go here, which is impossible because there are only 3 even digits, so one of these is guaranteed to be even, or she goes this path, which is possible. So then she has to go that way. And we have 5 odd digits in box 2, so this can't be odd, that's even, which means we have 4 evens in row 2, so this can't be even, that's odd. So she must go this route. We have... she does have to go... F does have to go from that cell. We don't know which, though. We do know that this digit, these 2 digits are even and they are next to each other with a difference of at least 5. Therefore, they must be a 2-8 pair. Therefore, this is 4, 6. B is 4, 6 then, which makes this 4 or 6. Four or 6 must be next to a 1 or 9 here. Therefore, D has to be a 5. Because D cannot be next to a grape, because if you subtract 5 from 5, you get 0 or less. If you subtract 5 or more from 5, you get 0 or less. If you add 5 or more to 5, you get 10 or more. So 5 can never be next to a grape. This digit is greater than that. We don't know which it is. Can go diagonally through here. Could potentially... Cannot go diagonally here. It blocks FP's route. So blue has to go this route. We have 4 even digits in row 6, so this cannot be even. It's odd, which means she has to go through that path. So has to go this way, has to go there. P again must go here for the odd digit. So it comes from this path. Okay. B has to be the same here, here, and here. So these are all B. A is here. A has to be here. C is here. C is here. So C has to be one of these 2. E is not the same as D. And again, 5 cannot be next to a grape. So where is 5 in box 9? It has to be here, which makes this an actual C. So this is C. E is here, E is here. E has to be one of those 2. We don't know which. 9 can never be here. If this is 9, no digit is going to be greater than it. So this has to be 1. Since this is 1, that forces this to be 6 to be 5 or more away from it, which makes that 4, which means B has to be a 6. So B is a 6. This is 1. If we had 1 and 9 here, 3 and 7 are not going to be 5 or more away from each other. So this cannot be 9 here. It must be 7, which makes this a 3-9 pair here. Okay. A is not 6, obviously. C is here, C is here. So C has to be one of these two. 3 or 9. Okay. Can F go this route? Yes, that seems fine. F can also go straight down, right? Actually, all the digits in column 2 have to be odd because we have 4 evens already. This is 2 or 8 remaining in column 3. We have 2, 4, 8 here, 2, 4, 8 here. Where is the even digit in other even digit in box 1? It has to be here, and it is a 6 because there's no other place for it in that box. Okay. P definitely has to go diagonally because this is an even cell. Cannot go this direction because that's even, so P has to go here. So that is the path that she takes. These have to be, these are 3-9 pair. So we have a 3-9 pair here, which eliminates 3 and 9 in the rest of column 6. So it's 1, 5, and 7 here. No 5 here. 1, 5, or 7 there. So C and 9 is 3 or 9. This becomes a 1, 7 pair here. So the remaining digit for the cupcake is 5. Okay. E is 1 or 7. And if E were a 1, the problem is 7 would have to be here then. And it's only the only odd digit which it can be 5 or more away from is only 1. So that's not possible. So this cannot be 1, which means E has to be 7. So E is 7. That leaves this as 1. We have 1 here, which is only 5 or more away from 9 out of 3 or 9. So this is a 1-9 pair, which eliminates 1-9 in the rest of the box. This can't be 9, that's 3. This is 9, which makes that 3. So C is 3, so that's 3 also. That's 3 in the corner. We celebrate because we're getting close to solving this. This digit is not 6, and it cannot be 2 because 2 is not greater than any other even digit. So it's 4, 8 here. This could be 2, 4, or 6 here. We don't know. This is 2, 4, 8, 2, 4, 8. This is less than another digit, so it has to be 2 or 4, which means where's the 8 in row 8? It has to be one of these two digits here because it can't be that one. So this can't be 8. It's 4, which is greater than 2. That means this can't be 2 for the cupcake here. It's 4. So this becomes a 2-8 pair in row 8 here. That leaves a 2-8 pair in column 6 for the even digits, and this is 6-8 as a pair for the remaining digits in row 9. Okay. This digit is greater than that, so it cannot be 2. Cannot be 4 because of the 4 in the column that matches that cell. So A has to be 8. So A is 8, which makes this digit 2, which makes that 4. This 2 eliminates 2 here, so that's 8. 8 eliminates 8 here, so it's 6, which makes that 8, which leaves 2 remaining in that column for the even digits. 2 eliminates 2 here, so it's 8 and 2. That leaves 4 remaining in box 2, and this becomes a 6-8 pair. This can't be 8 because of 8 in the column, so that's 6. This is 8, which makes that 4. That leaves that as 2. We have a 4-6 pair remaining in column 7. This can't be 6 because of 6 in the row, so that's 4. That's 6 there. 2 means this cannot be 2 here or here. 6 can't be either of these also, so 6 has to be 1 here. That leaves this as a 4-8 pair here. These two digits are 5 or more away from each other. This digit is greater than that. Four eliminates 4 here, so that's 8, which makes that 4. 8 eliminates 8 here, so 2, which makes that 8. We already knew that, though, so that wasn't that much information. This cannot be 4, 6, or 8 because of 6 or 8 in the box and 4 in the column, so this must be a 2, which makes this 8, which makes that 2. That leaves the remaining 2. We have 8 2s, right? Yep, the remaining 2 has to be here, which means that's even, which means the remaining digits in row 4 are odd. In box 5 are odd because we have 4 evens in the box. That leaves this as an even digit here, which is a 4. Okay. So we just have to figure the rest out from the clues that we have. These digits are 5 or more away from each other. What are the remaining digits in column 1? We have 1, 3, and 9, right? 3 can only be next to 9. 9 can be next to, has to be next to 3 here. And 1 could be next to 7. Okay. We've got all those figured out. Remaining digits in column 4, we have, what, 3, 7, 9. Remaining digits of column 5, we have 1, 3, 5, and 9. But 9 obviously cannot be in the lesser part of the greater than sign. Okay. Remaining digits, so 3 eliminates 3 as a possibility here. Okay. We have 1, 5, 7, 9 remaining in box 3. We have everything remaining in every other cell, though. So only restrictions are going to be, digits in columns or rows. One, 3, 5, 7, 9. No 7 here. No 3. No 3 or 7. No 3 or 7. No 3 or 7. No 5 here. No 5 here. No 3 here. No 3 here because of 3's in the column. 5 can't be either of these cells because of 5 in the row. So where's 5 in box 6? Has to be here. That eliminates 5 from being there. That also eliminates 5 in the rest of row 5. So whereas the 5 remaining in row 4 has to be here. This is just all normal Sudoku. That eliminates 5 from being here and here. Where is the 5 in box 2? Has to be here, which eliminates 5 in these two cells. which means where's 5 in box 3 has to be here. That eliminates 5 from being here. We have 8 fives, right? 1, 2, it's kind of hard to see. 1, 2, 3, 4, 5, 6, 7, 8. Yep, we know where the last 5 has to be. It has to be there. Okay. We have a 1-7 pair in box 5. That eliminates 1 and 7 in the rest of the box. So this cannot be 1 or 7. This is a 3-9 pair, which eliminates 3-9 in the rest of the row. So where is, we have a 1-7-9 triplet in box 6, which eliminates 1-7-9 in the rest of the boxes. Can't be 1, 7, or 9. It's 3. That eliminates 3 in the rest of the row. In row 4, where is the 3 then remaining? In box 4, it has to be here. This has to be 5 away from each other. This is definitely 7 or 9, which can only be 5 away from 1 out of 1 or 9. So this is 1. This can't be 1 or 3. That's 9. That eliminates 9 in the rest of the row and box. This one also eliminates 1 in the rest of the row. So it's 7, 9 as a pair. 1 eliminates 1 here. One of these digits is a 7. Okay. We have a 1-3-7 triplet in row 3, which eliminates 1, 3, and 7 in the rest of the row. So this can't be 3 or 7. It's 9, which makes this 1, which makes that 3. That's 7. That makes this 1. 3 eliminates 3 here, so it's 9 and 3. 1 eliminates 1 here, so it's 9 and 7. 7 eliminates 7 here, so it's 1, which makes this 9, which makes that 7. 1 eliminates 1 here, so it's 9 and 1. 7 eliminates 7 here, so it's 1 and 7. 3 eliminates 3 here, so it's 7. This can't be 3 or 7 now, so it's 1. This can't be 1 or 7, so that's 3. 7 eliminates 7 here, so it's 9 and 7. 9 eliminates 9 here, so that's 3 and 9. Oops, did we mess up? We must have messed up here somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9 twos. 1, 2, 3, 4, 5, 6, 7, 8. It's really hard to see. 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9 fours. 2, 3, 4, 5, 6, 7, 8, 9 fives. 1, 2, 3, 4, 5, 6, 7, 8, 9 sixes. 1, 2, 3, 4, 5, 6, 7, 8, 9 sevens. 1, 2, 3, 4, 5, 6, 7, 8, 9 eights. I think we have the right amount. 1, 2, 3, 4, 5, 6. 7, 8, 9 nines. Let's remove the coloring. Maybe that's distracting us. Okay. Okay, green grape sits between two digits with a difference of at least 5. Okay, 1 and 9 are different from each, are 5 or more away from each other. 2 and 8 are. 1 is 5 or more away from 6 and 7. 3 and 9 are 5 or more away. It says 3 and 9 here, so is 1 and 9. So all the grapes are done there. Greater than signs, 9 is greater than 3. 8 is greater than 4. 6 is greater than 4. 4 is greater than 2. 3 is greater than 1. I don't know why this doesn't work. A, both are 8. B, both are 6. C, both are 3. D, both are 5. E, both are 7. T is the red one and goes through diagonal here. Boom, 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 boom. To 3, to this route, to here, to here, to here, to here, to here, to here. Okay, oh, well, that doesn't change anything. Huh. I guess I messed something up. It seems fine, though. Everything checks out. Um, huh. That's interesting. Um, I am confused. Oh, I see it. We have 2 9s here, and we have 2 1. I don't know how that happened. That's weird. Okay. Well, that's the issue. Um, huh. Okay, that is problematic. How did we mess that up? That's weird. Okay. That's fine. 1 9 as a pair. Yeah, that's weird. How I completely botched that. 1 7 as a pair. That's fine. So no 1, no 7 here. 3 9 as a pair. We have 1 3 9 there. 5 can't be here. 5 can't be here. So 5 is guaranteed to be here. Yeah, that was a weird. I don't know how I messed that up. Anyways, no 3 or 9 here. We have a 1 7 9 triplet in column 8. So this can't be 1 7 or 9. It's 3, which means we cannot have 3 here. 7 or 9 have to be next to 1. This has to be 3 here, which makes this 9. So no 9 here, no 9 here, no 9 here, no 9 here. We have a 1 3 7 triplet in row 3. That leaves this as 9. So this is 9, this is 3, that's 9, which makes this 7. 9 eliminates 9 here, so it's 1 and 9 here, 7 here, 1 here. That makes this 9 and 1, which makes this not... Wait. How am I keep getting this? This is weird. I don't know how I messed this up. This is very strange. Have to go back and figure out where I messed up here. Right, that can't be 9. Okay, I don't know. I'm not sure where I messed up here. 1 5 7 9. No 7 here, no 7 here, so it's 1 5 or 9. This can't be 5 though, so this is 1 or 9 only. Which means 5 is one of these two, so 5 cannot be here or here. Okay. Maybe it was the 5s in this area. I don't know. Remaining digits of column 2. We have 3, 5, 7, 9. Okay, remaining digits of column 3. We have 1, 3, 7, 9. Okay. Okay. Hmm. Okay, remaining digits of box 6 are 1, 3, 5, 7, 9. No 5 here, no 3 in these spots. We have a 1, 7, 9 triplet, which eliminates 1, 7, 9 in the rest of the column. 9. So this has to be 5, which means these can't be 5. Oh, well, they couldn't be 5 anyways. 5 eliminates 5 here. So this does become a 1, 7 pair, which makes this 5. Huh. I don't know. That's weird. 1, 7 as a pair, eliminates 1, 7 in the rest of the box. So this is a 3, 9 pair, which forces this to be 5. Therefore, this is not 3 or 9. It's 1, 7 as a pair. We have 1, 7, 9 as a triplet here. That forces this to be 3. These can't be 5 anymore, so 5 has to be here, which means this can't be 5 anymore, so this must be 5 here. 3 eliminates 3 from being here, so this is 1, just 5 or more away from 7 or 9. 1 and 7, 9, eliminate 1 and 9 here, so that's 3. This can't be 1 or 3, it's 9. There's no 9 here, no 9 here. One of these two is 9, so this is 1, 9, 1, 9, that's a pair. That forces this to be 7, that 1, that 7, that 1, which makes that 9, which makes that 1. Maybe this was, I don't know. Nope. Can't be, can't, what is going on? How am I messing up basic Sudoku here? This is annoying. How? What's going on? Uh, hmm. Yeah, because C, D, and E cannot be the same digit. Um, that's causing some issues here. So the evens seem all fine. Okay. E is the same, D is the same, and C is the same. Three can only be next to 9 if they're both odd. Around the grapes. This is weird. I don't know how I'm running into this problem. This is strange to me. 7 must be... How? I'm so confused. Okay, let's go back to maybe I messed something up with the C, B, and D. Well, D, I think no, D has to be a 5. That's guaranteed. The problem is this correct? Well, yeah, this has to be 1 and 7. Right, because you can't have 1 and 9 here because 3 and 7 are not 5 away from each other. So 1 having to be, this can't be 9 because it's less than that digit. And 9 is never less than another digit in normal Sudoku. So this must be 1, that's 6, right? That's all kosher for. And you can't have 7 be here because 3 would also be there, and they are not 5 or more away from each other. So this must be 1 and 7. This must be a 3-9 pair here. We can't have 7 and... Oh, this is 1 and 7 as a pair. And if we try to have 1 here, 7 cannot be next to another odd digit, which is 5 or more away from it. So that's pretty problematic. This has to be 5 because it's 5 cannot be the same as E, and 5 cannot be next to a grape. What am I missing? Ugh. I'm running into contradictions here, which is bad, obviously. This has to be 3-9 as a pair. This has to be 1-7. And this must be a 5. Those are all the same. 1 and 9 here, 1-5-9 here, 1-5-9 here. That leaves us as 1-7-9 because we cannot have a 5 in one of these two cells because 5 is guaranteed to be one of these two cells. This can't be 3. Where's the 3 in row 6? It must be here. So this is 1-7-9 here. That leaves a 1-7-9 triplet in box 4. And this can't be 1. It's 7-9, which is guaranteed to be 5 or more away from 1 here. That leaves that as 9. This cannot be 1 here. It's 7-9. No 9 here. We have 1, 3, 5, 7. No 1s here. No 5s here. We have 3-7-9 here. 3-7-9 here. 3-7-9. No 9 here. This can't be 9 because of 9 in the row. Where is the 5? It has to be here. That eliminates 5 from being here. This leaves a 3-5 pair here. Okay. This can't be 5 because of 5 in the column. So that leaves this is 3, this is 5. 5 can't be here. Ugh, we still run into the same problem. This becomes a 3-9 pair. That means this can't be 3 or 9. 5 can't be here. Where's 5 in row 5? It has to be there. Which leaves us as 1-7, and we still have the same problem that we keep running into. 1-7 is a pair, eliminates 1-7 here, so that's 5, which means this can't be 5 here. It's 1-7-9 here, which leaves this as a 5. This can't be 7 because of 7 in the column. Can't be 9, so it's 1 or 3. 1-3-7 as a triplet, eliminates 1-3-7 in the rest of the row, so this is 9, which makes this 3, that 9. 3 eliminates 3 here, so it's 7, which eliminates 7 here, so it's 1, which makes this 9 and 1. Eliminates 1 here, so it's 7. This can't be 1 or 7 or 9. What am I messing up here? Ugh, this is really annoying. I might have to go back and make sure that my coloring was kosher. Ugh, this is so bad. Okay. Again, this is too many cells to get to A or to exit out going this way, so that doesn't work. Cannot go here because then blocks the other rat from exiting out ever. So it has to go this route. Other rat has to go that route. We have blue going out here. Red. Blue cannot get 1, 2, 3, 4, 5, 6 cells in a box, so it has to go out that way to teleport. That means red cannot go 1, 2, 3, 4, 5, 6 either, so it has to exit out that way. Can't go here 1, 2, 3, 4, 5, 6. So that means the can never reach this cupcake, which means blue has to reach this cupcake. So blue has to go this way. Red has to go out here. Oops. Red has to go here. Blue has to go here. This is and from the again the grapes, we know that 4 and if you had 3 cells which were even next to a grape, they would have to be 4 and one of them would have to be 4 and 6, which can only be next to 1 and 9 on the grapes. But that's not possible for either of these scenarios. So therefore, the P has to be the top rat, which is the visit the odd digits, and blue has to be the even digits. So these are all blue, which means the remaining digits in row 9 are all red. So blue can, F cannot go through that route. F has to go that way, which blocks P, so P has to go that route. So we know C is red also. This has to be blue. You have to go blue that way. This has to be a red cupcake. Blue has to go here. That's too many. That's 4 blues in row 8, so these are all red. We have 5 reds in box 7, so these are all blue. We have 4 evens in box 9, so this has to be red, which means E is red. Well, we already knew that. So we have 5 evens in, sorry, 5 odds in row 7, which means B cannot be odd, it's even. That leaves that as even. We have 1, 2, 3, 4 evens in column 7, so the rest are odd. We have 5 odds in box 6, so this is even. We have 4 evens in column 8, so this is odd. We know C is odd. We have 4 evens in box 3, so this must be odd. You have to teleport to here, so to get there, these have to be all odd. Therefore, the rest are all even. That's fine. Has to go this path. D is guaranteed to be odd. Teleports to A. Again, cannot go any of these ways because the problem is we have 3 evens in the box. So necessarily has to go this route. But that means it has to go here, which means it has to get out this way. Going from C, P cannot reach the cupcake except through D. So it has to go that route, which means it has to come this way. Front to E, which means it must go this way. So these are all red. Okay. Cannot go straight down. That would be 6 reds in column 5, which is not possible. So I have to go this route. This digit is smaller than that. It must be next to a 4 or 6 because these are 5 away from each other. It can only be a 2-8 pair, so this is 4, 6. This then is less than another digit, so it must be a 1. Cannot be 9. That leaves us as 6. That is 4. B then has to be 6, which makes that 6. 1, again, cannot be next to 9. D has to be 5 because the rest of the odd digits are next to a grape, which 5 cannot be. If we try to have 9 here, this would be a 3, 7 pair, which are not 5 apart from each other, so this is 7. This is 3 or 9. That leaves the remaining odd digits as 1 and 7. So this is 1 or 7 here. Remaining digits next cannot be next to a grape. So this is 5. That leaves C as 3 or 9. And we have a 1, 7, 1, 7 pair here. A 3, 9, 3. Well, yes, because C has to be here. So this has to be a 3, 9 pair here too. Which leaves this as 5. Ugh. 1, 3, 7, or 9 here. So if this were 7, it would have to have a 1 here. So that's not going to work. Which means one of these is 1, which can only be 5 away from 9, not 3. That leaves this as 3. So C is 3. That makes this 9, which makes that 3. This 1, 9 pair eliminates 1 here, so it's 7. Which makes this 7, which makes that 1. This is still leading to the same problem. Ah! This is pretty annoying. 2, 4, and 8 here. The 2 cannot be here because it has to be greater than another even digit. This is less than another digit and cannot be 6, so it's 2 or 4, which means 8 has to be one of these two digits, which eliminates 8 here. So that's 4. There's no 4 here. It's 2, 8 as a pair, which eliminates 2 there. So that's a 4. A cannot be 4, cannot be 6, and it's greater than another digit, so it must be 8. That leaves this as a 6 to be greater than 4 here. That leaves a 2 there. Blue has to go around the odd digits to reach. So blue has to go this route, which means red has to go this route. We have 4 blues in column 4, so this can't be blue, it's red. We have 5 reds in box 2, so this can't be red, it's blue. We have 4 blues in row 2, so this can't be blue, it's red. 8 eliminates 8 here, so that's 2 and 8. This cannot be 8 here, so that's 2, which makes this 4. 2 eliminate 2, and 4, 6 makes this an 8 to there. Okay. Maybe it was this portion that I messed up on. I don't know. We have to go this route because we cannot go diagonal here. So that's blue. We have 4 blues in row 5. This cannot be blue. It's red. So no, it does have to go down. We have 4 blues in column 2. This can't be blue. It's red. We have 5 reds in box 1, so this has to be blue. This can't be 2, 4, or 8. It's 6. This is 2, 6 as a pair here. This is 4 and 8 as a pair. This is 2 and 8 as a... This digit is less than 4, so it has to be 2, which makes that 8. So 2 can't be here. Where's the 2 in box 6? It must be there. This has to be a 4, 6 pair. Cannot be 6 because of 6 in the row, so it's 4 and 6 there, which makes that 8. This is 4, 6 as a pair here. We have 5. Whoa, that's really different. How did we get that? I don't know. I don't know where... I don't know. I don't know how I messed that up. Okay, well, I guess that's good to know. Well, we just completely messed up the... Yeah, we messed up the coloring. I don't know. I'm not sure how I messed that up. Anyways, this is red. These are red. I don't know if I colored these already. This has to be blue because we have 4 blues. That's weird. Anyways, this can't be 2, 6, or 8. That's 4, which makes this 6 and 4. I don't know how I messed that up, really. Weird. I don't know. The path has to go this route. That's fine. Oh. Does not have to go there. Okay. Never mind. That's where... Yeah, okay, never mind. Does not actually have to go here. But does have to go here. Can't go all the way up here. That's too many even digits in the column. So definitely has to go there. That... Yeah, okay, never mind. Never mind. Okay. Cannot go 3 reds up that way because that's too many reds in the column, so definitely has to go this route. So this is all still the same. That leaves this as blue. That's 4 blues. That can't be blue. It's red. So the path does have to go this route. Has to go through here. Has to go here. Has to go this way. Otherwise, there's no way to reach through. Oops. Okay, well, this is 2. This is 8. Where is 2 in box 6? Has to be here. This is 4, 6 as a pair. That forces this to be 8. No 4 this way. Where's 4 in box 2? It's there. That leaves this not as 2, 4, or 8. It's 6. That means that 2. That leaves that as 8. Therefore, that's 6. This can't be 6. It's 4. That's 6 there. That leaves that as 4 there. This can't be 4. It's 2, which makes that 4. That leaves that as 8. This can't be 4, 6, or 8. Therefore, it must be 2. Which makes this 8, that 2. This can't be 2 or 6, so this is a 4, 8 pair here. Maybe it was this. Maybe it was the assumption that this had to go that way? Huh. Maybe. We know one of these is a 6. So yeah, maybe that was the bad assumption. That's a pretty bad assumption, I guess. Okay. Though that's kind of... I guess. Yeah, it was just a bad assumption that I had to go down. Okay. Yeah, That's tricky though. Hmm. Interesting. Hmm. Interesting. Remaining digits. Column 7. We have 159. Obviously, this is 1 or 9. This is 1, 5 or 9, 1, 5 or 9. That eliminates 5 from the rest of the box. So this is 179. 179 there. Where's 2 in row 4? Again, it can only be here. So this is blue. And it has to be a 2. That leaves this as red because we have 4 blues in column 4. 2 eliminates 2 here, so it's 8 and 2. 8 eliminates 8 here, so it's 4 and 8. Oh, we already knew that. Anyways, these are guaranteed to be red. Okay. Remaining digits of column 4 are 379. Remaining digits of... Well, I mean, now we know that it can't go down that way. So doesn't it have to go that way? Interesting. Yeah, I guess I fucked... apologies, I messed up by basically going down this path. I don't know how I guaranteed that. That was... that's a pretty bad error. Okay. Anyways, remaining digits of column 5. We have 1, 3, 5, and 9. Obviously no 9 here because it must be less than that digit. This can't be 3 because of 3 in the row. Remaining digits of box 6, 1, 3, all of them. But no 3s here because of 3 in the column. No 5 here because of 5 in the row. We have a 3, 6 pair now remaining in row 6. That eliminates 3 and 6 in the rest of the box. We need access to a 4. It has to be here. So that's 4. Remaining digits then are 1, 7, and 9. Okay. So this is guaranteed to be odd. And these 2 digits have to be 5 or more away from each other. This is 7 or 9, which guarantees this is 1. So no 1 here. That means no 1 here. This cannot be 1. No 5 here. No 1, 7, or 9. So that must be 3. So this is 3, which makes that 5. That eliminates 5 here, and then we have the scenario where I was running into problems, but now it's no longer there. So that leaves this as 5 here. This cannot be 9. Okay, so then 5 eliminates 5 here and here. Where's the 5 in the box? Can only be here. That eliminates 5 here. Where's 5 in box 3? It must be there. Remaining digits of row 2, we have 1, 3, 5, 7, 9. No 5, 7, 1 there. No 5 there. Where is the 5 in row 2? It has to be here. That leaves this digit as cannot be 5, 1, 3, 7, or 9. That's fine. And 6 is one of these two. And... huh. Therefore, this is remaining digits here are 3, 6, and 9. This is 1, 3, 6, 7, 9. No 1 because of 1 in the column. So if this is 6, doesn't really change anything. So I guess we have to make that assumption that that's 6 and then see that it leads to a contradiction. If this is 6, this becomes 3, that's 9, this is 6 there. Oh, we have a 1-9 pair here. Okay, that's where, yeah. So 1-9 pair here, which eliminates 1-9 in the rest of the row, so it can't be 1 or 9. It's 7 there, which eliminates 7 here. That eliminates 7 here, so it's 1, which makes that not 1, so it's 9 and 1. 1 eliminates 1 here, so it's 9, makes that 7. 9 eliminates 9 here, so it's 1 and 9 there. 1 eliminates 1 here, so that's 9, which makes neither of these 9. 9 eliminates 9 here, so it's 3 and 9. 3 eliminates 3 here, so it's 1. So this cannot be 1 here. 9 eliminates 9 here, so that's 3. This is not 3 anymore, so it's 7 and 3 there. This can't be 3, 7, or 9. It's 1. None of these can be 3. 3 eliminates 3 here. So with that, yeah. So that was the bad assumption here, right there. Ugh. Anyways, that leaves this as 6. That's 3. This is now blue. This is red that way. Okay, so that was the major error. So blue has to go that way, and then has to go there. 6 eliminates 6 here, so this is 9, which makes this 7. 9, 7, and that's 6. So red goes around this path, and we have the paths now correct when we had it messed up before. Anyways, this is, whoops. This is now 9 here, that's 3, and this must be 1 and 7. Apologies for that. Experiment completed successfully. Test date, March 4th, 1975. Cells visited 74, grapes eaten 6, one-way doors used 5, teleports used all 5. As predicted, teleport C overheated shortly after P had used it. I switched it off immediately to be on the safe side. It appears that sandwiching a teleport between two others has been the cause of this ongoing problem, and it took until today for me to cotton on. Elliot clearly realized a while back and decided not to mention it. Elliot seems to be sabotaging the experiment. He's now explained that the overlapping energy field from the neighboring portals are somehow interfering with the middle one, their combined close proximity having unintended effects. I'm guessing this all has something to do with his SRT diagram, but it would probably be unwise for me to ask about that, given how I know about it. Yeah, that was a pretty bad assumption. Yeah, that was just one bad assumption, I feel. Otherwise, would it be challenging? Just challenging? Execution-wise, I don't know. I just messed up. Yeah, it is what it is, though. I think it's challenging is still a valid way to describe it. Oh, we also missed the... That's the continuation of that path because it cannot go down. So 74 cells visited. Which ones were not visited? This 4, this 6, this 9, 2, 9. So 1, 2, 3, 4, 5. This 3, 6. And there should be a 4th. There should be another one. A 2 here. Okay. Interesting. Anyways, I hope you enjoyed my solve, even though I made a really bad assumption here. That was a pretty bad, yeah. And I don't know, I completely messed the Sudoku part here, so that was pretty bad also. Anyways, as I said, I hope you enjoyed, and I'll see you next time on Frank Puzzles. Take care.